Hey, pre-calculus people, welcome to section 6.5. We are transforming sine and cosine in this section. That is just shifting. So if you're comfortable graphing the sine and the cosine, and you're also comfortable with the end of chapter 2 when we talked about transformations, you should have no problem with this section. All right, so when we are given something of the form, previously we were just given a sine bx, and you've gotten really good at graphing that, and y equals a cosine bx. No problem, right? We can graph those by drawing our little boxes. This is how high and low the box goes, and this determines the width of the box or the period of the trig function. Well, this time we're going to throw in the h and the k. So just like when we did transformations in chapter 2, this follows the exact same process. All right, so let's just remind ourselves the a out front is going to determine the amplitude, or how high and low the curve goes. The b in here, now notice the b is outside of the parentheses, so that's going to be important. We'll talk about that when we look at an example. So the b is the period, how long it takes one complete wave. H is going to be, well, the h is inside the parentheses with the x, so this is going to be my horizontal shift, h units. And k is going to be my vertical shift, k units. Right, so my suggestion is first to graph the trig functions lightly without the shifts, then do the shift, okay? Not too bad, right? So let's look at an example. Let's graph 3 sine 1/2 x plus pi plus 2. Right, so first we're going to graph y equals 3 sine 1/2 x. And then we're going to shift. Well, remember, if it's plus inside the parentheses with the x, we're going to shift left pi units. And if it's positive outside the parentheses, we're going to shift it up that quantity, up 2 units. Okay. The amplitude is 3, and the period is 2 pi over 1/2. Which is 4 pi. Remember, dividing by a fraction is equivalent to multiplying by the reciprocal. So I'm going to go, let me see, the amplitude is 3. So 1, 2, 3, 1, 2, 3. So we're going to graph this guy first. So we're going to go up 3. The period is 4 pi. So I'm going to go out 8 units because I just like 8. 3, 4, 5, 6, 7, 8. So when I draw one little box, so we're just doing one period here. When I draw one box, we're going to go up 3, down to -3. So we're drawing it without the shift. And when I draw my boxes, I like to draw it in multiples of 4 on my x-axis because we're going to divide the box into fourths. So it's a lot easier if my tick marks are in fourths. So this is going to be 4 pi. Right? Halfway between 0 and 4 pi is 2 pi. Halfway between 0 and 2 pi is pi. So 1 pi, 2 pi, then that point's going to be 3 pi. So now we're going to plot our 5 important points. It's a right side up sine function. So remember, we start in the middle of the box, we make our hill, and then we make our valley. Right? And these are the 5 important key points that are going to happen at each 1/4. So at 0, we're at 0. At pi, it maxes out. Halfway, it crosses. 3/4 of the way, it goes to the bottom, and then it goes back here. So here's the graph of one wave of y equals 3 sine 1/2 x. Now we're going to take this guy, we're going to shift it pi units left and 2 units up. Now look carefully at my x-axis. Pi is a distance of 2 blocks. So the way I drew it, pi is 2 blocks. So I'm going to take all of these 5 important points, I'm going to move them 2 blocks, which is equivalent of a measurement of pi to the left, and then up 2 units, which would just be two tick marks because I made each of those 1. So I'm going to take this point, I'm going to move it 2 blocks to the left. I'm going to use a darker color. Let's do green. I'm going to move this point 2 blocks to the left, which is equivalent to pi. So 2 blocks to -pi, and then I'm going to go up 2. So this point moves over pi up 2. This guy's going to move over pi up 2. So my new y-intercept is 0, 5. And we can always plug that in. We could plug this in, and if we put 0 in here, 0 plus pi is pi. 1/2 pi is pi over 2. Sine of pi over 2 is 1. 3 times 1 plus 2 is 5. All right, so 2 pi, we're going to move it over pi to pi and then up 2 units. This guy I'm going to move over pi up 2, so it's going to go to 2 pi negative 1. 4 pi is going to go over to 3 pi and up 2. All right, so here's my shape. We can see these 5 important points. And this would be one wave. All right, so let's identify a few of these points. That's now the point 0, 5. This is the point, let me see, we started at 0, we moved over pi, so negative pi, and we went up 2. All right, so forth and so on. Let's just identify that point. It was at 3 pi, we moved over pi, so to 2 pi, and then we moved it up 2 to negative 1. There we go. Let's just write the domain. Let's see, the domain here. So even though we just drew one period, the domain actually is all real numbers. We only are showing it from negative pi to 3 pi, but the domain is all real numbers. Of the sine curve is always all real numbers unless otherwise stated. Be careful with the range though, because now my range, it was negative 3 to 3, but I moved it up and it's now at negative 1 to 5. So this would be negative 1, that's 5. So my range is now negative 1 to 5 because I shifted negative 3 to 3 up 2 units. All right, and that's it. Let's do a cosine. Y equals 4 cosine 2x minus pi over 4 minus 3. So let's first graph y equals 4 cosine of 2x. And then we're going to shift it. Well, if it's minus pi over 4, we're going to shift it right. Oops, spell right. Right pi over 4 units. And we're going to shift it up, down 3 units. All right, so looking at this graph, this is going to determine the amplitude. The 2 is going to determine the period. So the amplitude is 4, and the period is 2 pi over 2, which is pi. All right, so we're going to draw one box. I'm going to ignore the whole thing. I'm just going to draw 4 cosine 2x. So I'm going to go up 4. All right, so here's 4. 1, 2, 3, 4. Actually, I'm going to make 4 here. I'm going to make this 8 because when I shift it down, if I made that 4, I'm shifting it down 3 units. I'm going to lose some of my picture. So let's make that 4 and this 8. So each step up is a shift of 1. All right, and then my period is pi. So again, I'm going to go out 8 tick marks because I like going out in multiples of 4. 1, 2, 3, 4, 5, 6, 7, 8. So here is pi. 1, 2, 3, 4, 5, 6, 7, 8. Here is 2 pi. So we're going to graph 2 periods this time. 1, 2, 3, 4, 5, 6, 7, 8. Here's negative pi. So one box goes between, oops, nope, 4. I'll use that one later. Sorry, ignore that. And negative 4 to pi. So this is where I'm going to get one cosine curve nice and squished in there. Remembering the cosine curve starts at the top, makes like a U shape and ends at the top. Where it crosses in the bottom are our 5 important points. So let's just identify. Halfway through is pi over here is pi over 2. Halfway between 0 and pi over 2 is pi over 4. So 1 pi over 4, 2 pi over 4. This would be 3 pi over 4. All right, so let's draw one. Oh yeah, I'll do it with this guy. So we're going to start up here. We're going to cross at the first tick mark, bottom out at the second, cross at the third. We're going to do this. All right. We're going to draw a second period over here, but because I'm shifting it right pi over 4 units, I'm actually going to draw my second period to the left of the y-axis, just so I don't lose any of my picture when I shift. So halfway, this is going to be negative pi, this is negative pi over 2, negative pi over 4 is halfway in between, negative 1 pi over 4, negative 2 pi over 4, this would be negative 3 pi over 4. All right, so I start at the top, cross at the first tick mark, bottom out in the middle, 3/4 of the way I cross, and I'm back up here. All right, so this is the graph before the shift. Now we're going to take this whole thing, we're going to move it right pi over 4 units and down 3 units. So each of these, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 points. I'm going to move right pi over 4 and down 3. So notice pi over 4 is the distance from here to here. So on my graph, that's 2 tick marks. So I'm going to move it right 2 tick marks and down 3, each of these points. So right 2 tick marks, down 3, 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 right 2 tick marks, down 3. Here we go, right 2 tick marks, down 3, right 2 tick marks, down 3, right 2 tick marks, down 3, and my last one, right 2 tick marks, down 3. So we can see the shape right here. It's going to do this. It's going to go down. It's going to go up. Whoop. There we go. And it's going to continue like that forever. All right, so let's just label a couple of important points. So this guy was at pi, right? We went over pi over 4. So pi plus pi over 4, well, this is 4 pi over 4 plus pi over 4 would be 5 pi over 4 right here. So this point right here is 5 pi over 4. And then we went from 2 down to -1. Right. How about this guy right here? Let's see if we can identify that one. Let's be a little challenging. That came from here. So we were at pi over 4. We moved over to pi over 2 and then down to -3. So it's pi over 2. -3. All right. My intercept, well, that point went over and then down, so it's going to be 0, -3. All right, let's just try one more, and you guys can work on these on your own. Let's graph 2 periods of -1/2 sine 3 times x plus pi over 3 minus 3/2. Right, so first we're going to graph y equals -1/2 the sine of 3x. All right, and then we're going to shift it pi over 3 units. Now because it's plus inside the parentheses with the x, it's going to be on the x-axis, and we're going to shift it left. And then we're going to shift it 3/2 units. And we're going to shift it down. If it's minus outside, we shift it down. The amplitude is -1/2, and the period is 2 pi over 3. So this is getting a little complicated. All right, 2 pi over 3. All right, so let's draw one period. So the amplitude is, whoops, it should be +1/2. Amplitude's always positive. All right, keep in mind, this is the regular sine curve, but because it's upside, because of the negative, we're going to flip it upside down, and we're going to draw it like this. And these will be my 5 key points. So the amplitude is 1/2. So let's do, when we're shifting it down 3/2. So here's, I'm just going to do, this is 1, this is 2. Right? We're going to do -1, -2. So the amplitude is 1/2. So it's tiny. It's going to be here. And the period is 2 pi over 3. So I'm actually going to go out 8 tick marks again. 3, 4, 5, 6, 7, 8. And I'm going to make this my box. Nope, sorry, I did it again. 1/2 is my amplitude. Ignore that one. So we're going to go 1/2, and we're going to go out to 2 pi over 3 is my period. So 1/2 in this little box right here. Ignore this guy. Right there. So that's my box of interest. Here, let's get to this so you can't even see it. Right there we go. All right, so that's my box. All right, so we're going to do halfway in between 0 and 2 pi over 3. Well, half of 2 pi over 3 is pi over 3. Between 0 and pi over 3, halfway is half of pi over 3, which is pi over 6. So this is 1 pi over 6, 2 pi over 6. This is going to be 3 pi over 6, and 3 pi over 6 is pi over 2. So those are my 4 important points. The sign starts at 0, 0. And then because it's the negative sign, it's going to bottom out a quarter of the way through. It's going to cross halfway. It's going to max out at 3/4 and then end here. Right there. So this is 1 period of -1/2 sine of 3x. All right, so let's do another one. I'm going to go out another 8. 1, 2, 3, 4, 5, 6, 7, 8. So we double this. This is going to be 4 pi over 3. And we're going to draw one more in here. Okay. So we're going to go halfway. Well, halfway in between. Well, this gets tricky. These are, so here's my quarters. We have 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. So that one's going to be 5 pi over 6. Remember, every 2 tick marks is up 1 pi over 6. So 5 pi over 6, 6 pi over 6, which is just pi, 7 pi over 6, and if you count right, it always works out, 8 pi over 6. So here's my new box. We start in the middle. We bottom out at the first tick mark because it's negative sign, cross halfway, max out at the third tick mark, and cross again. And so here is 2 periods of negative 1/2 sine of 3x. Now we have to shift it. I'm going to shift it pi over 3 units left and 3/2 units down. So now notice pi over 3 this time is 4 tick marks. We're actually shifting it a whole half of a period. So pi over 3 is from here to here, so that's equivalent of 4 tick marks. So it's 4 tick marks left, and 1.5 units down would be 3 tick marks down. So 4 units left, 3/2 would be 1.5, so it's going to be 3 tick marks down. So we're going to go 1, 2, 3, 4, 1, 2, 3. So this point goes to here. This point we're going to go 1, 2, 3, 4, 1, 2, 3 units down. 1, 2, 3, 4, 3 units down. Notice how they're all lining up if we count correctly. So 4 units left, 1, 2, 3, 4, 3 units down. 4 units left, 3 units down. 1, 2, 3, 4 units left, 3 units down. 1, 2, 4, 3 units down. I just did that guy? Yep. 1, 2, 3, 4 units left, 3 units down. 1, 2, 3, 4, 1, 2, 3 units down. There we go. And it's going to be like that forever. And that's my final answer. So this is the graph of y equals negative 1/2 sine 3x plus pi over 3 minus 3/2. All right, side note, be really super careful. So this graph right here is the same as this graph, 1/2 sine. What if we distribute the 3x? Wouldn't this be 3x plus pi minus 3/2? Right, same exact equation. I just distributed the 3. Right, but you have to be careful. The shift, if we look at this picture, the shift is not pi. The shift is only determined if we pull the coefficient of x out front, and then what's left inside the factor, that would be the shift. If we graphed negative 1/2 sine of 3x and then shifted it pi units, it would not give us the correct curve. So you must factor the 3 to obtain the correct shift. All right, so if we have y equals negative 1/2 the sine of 3x plus pi minus 3/2, we're just going to factor the 3 out inside of the sine. 3, if we take the x out, well, if we take the 3 out, we just divide this by 3. And this would be the correct shift. So it's really super important if you're given the equation in this form that you factor that coefficient out, and that's not the shift. The resulting numerical value inside the parentheses is the shift. All right, have fun with these guys.